Hey guys, what's going on? My Caveman Q here again, Paleo Problem Island, mycaveman.com. Got another edition of Monday Nights with Mike, live stream Q&A. Ask me anything, health related, you know the deal. And yeah, apparently we got me sipping some kombucha to start the show. Nice. Unfortunately, YouTube's a little squirrely in terms of when I know when I'm starting. Whatever, not a big deal. So yeah, put your questions down in the comment box down below. Although technically, with the way I've had it set up with the OBS, you can see it over there, so you can do it there. That being said, tonight, as always, though, it's any questions you guys want to cover, ask me them. Keep them rolling. But in the interim, I actually came across an interesting study regarding the use of psychobiotics and like what is that? And that refers to a concept which I've talked about the gut-brain axis before. In fact, what I'll do is I'll put a link to a video, my video on that topic right up here. I guess over there really more, but you know what I'm saying. So up top, I'll add a card for the gut-brain axis video. And the fact of the matter is our gut is inexorably linked to our brain. They are, your gut, when you say people say they have a gut feeling, it's not inaccurate. It basically is our second brain. And like I said, I was doing some research for a project for school and my doctorate, and came across some interesting articles. And I actually dropped them down in the description down below, so we'll be able to go through them together like we've been doing the last couple of weeks. So, I mean, hopefully you guys enjoy that format, and if not, let me know. As it stands right now, I have my master's. So after I finish my master's, that let me sit for my CNS exam, and God willing, I passed that test, and that's next Sunday. So I should theoretically have a little more time between that, fire cream, everything, doctorate program, all that fun stuff. At which point, I plan on getting back to doing some videos on a regular basis rather than just these. But yeah, all right, on with the show. So, psychobiotics. Let's open up the secondary screen. So we have this here one is by Sundar Nagnavel. I'm sure I butchered that name, but whatever. And unfortunately, this one doesn't appear to have a PDF available, but whatever. So this was published back in 2015, and Psychobiotics, the last psychotropics, right? So different types of compounds that will have beneficial or just effects in general on our brain. So, Psychobiotics. Oh, wait a minute. Is this one a... Oh, this one is an article. Oh, this is a letter. Whatever. I got it open. Might as well talk about it. Sir, psychobiotics are the most recent of those agents with hypothesized psychotropic properties. So this will be a little bit of an explainer on what they could be. They said Denon et al. Define psychobiotics as those living organisms that, on sufficient ingestion, produces a health benefit in those patients with psychiatric illnesses. This includes Bifidobacterium infantis, Escherichia, Bacillus, which, as you know, are the strains you find in Megaspore, Saccharomyces, Candida, Streptococcus, Enterococcus, and Lactobacillus acidophilus that can produce neurotransmitters including serotonin, norepinephrine, and gamma-aminobutyric acid, more commonly known as GABA, or modulate expression of neurochemical receptors like the endocannabinoid receptors, which we've talked about a whole bunch, which act on the postulated gut-brain axis to produce psychotropic effects such as antidepressant and anxiolytic effects. And let's see what that paper that is. Interesting. We'll see if that's available. The other one I actually did read through before this, so whatever. But through multiple studies, though multiple studies have demonstrated favorable effects of psychobiotics in animal models of depression and chronic stress syndromes, clinical studies have been scarcer. In a study of clinical subjects with irritable bowel syndrome, Bacillus infantis was demonstrated as effective and an alteration in pro-inflammatory or to anti-inflammatory cytokine ratio. Basically, it helped to improve the ratio of anti-inflammatory to pro-inflammatory chemical mediators. So in doing so, it should reduce inflammation. Similarly, Lactobacillus casei was shown to have beneficial effects in human subjects with chronic fatigue syndrome when compared to placebo by reducing the anxiety scores. In another study, daily administration of probiotic agents reduced the symptoms of psychological distress in normal, healthy volunteers, as measured by the Hospital Anxiety and Depression Scale and Coping Checklist. A concomitant decrease in urinary free cortisol further lends credence to the above observation. To summarize, the psychotropic effects of most of the probiotic strains can be explained under the broad tenets of psychoneuroimmunology. Yeah, say that 3 times fast. Furthermore, the development and application of psychobiotic agents might be easier than conventional psychotropic medication, given they might not be required to undergo the stringent and rigorous regulatory procedures as those used for regular psychotropic drugs. Elaborate studies on those microbiota involved in depression, anxiety disorders, and other stress-related disorders needs to be undertaken earnestly. The effects of such microbiota or probiotic agents on one's behavior, cognition, and emotional processes or emotive processes, along with possible mediators of their action, can further clarify the picture. So this is the quick little letter to the editor, I guess, where it's explaining what and how they could work and what they have been shown potentially to do. So unfortunately, this one does not look like it's got a full article available. And this is the one on GABA production by bacteria in the intestine. Let's see. Go back. Can I pull this one? And the answer is yes. Free text for some or all content determined by the publisher and subject to change. Yeah, it's probably not that interesting. But let's look at what's it. Significance conclusions first. Production of GABA by bifidobacteria exhibited considerable interspecies variation. Lactobacillus brevis and Bifidobacterium denteum were the most efficient GABA producers among the range of strains tested. Now, if you know, a lot of people that have issues with sleep, they will generally take GABA agonists. If the gut bacteria are able to produce GABA that in the gut, that is an excellent sign. They could have potential benefits, particularly for sleep and then just general mood benefits. But then even so, this is down there. Significance and impact of the study. Identification of optimal MSG conversion to GABA MSG. Oh, wow. Very interesting. Huh. Not only could it produce GABA, but it could do so from MSG, so monosodium glutamate. Particular culture elements of the commensal intestinal microbiota and demonstration this can occur under simulated in vivo conditions offer new prospects for microbiota modulation to promote health. This could be a game changer, especially for those who eat a lot of Chinese food with MSG and everything. MSG can cause cytotoxicity issues. Now, it's one of those controversial topics regarding whether or not, oh, it's not going to do anything. Oh, it's going to do something. Oh, it's not going to, it's probably going to do something. Glutamate is, particularly free glutamate, is neuroexcitatory, meaning that it can have exciting or stimulating effects on the brain, which can be problematic for some people. Because of that, MSG can be problematic. So, yeah. Oh, wow. Let's pull this one. Screw it. Let's go through this one first, because now I'm actually intrigued. And this is from 2012, so we've known about this one for a little bit. PDF. So basically, to assess the ability of human intestinally derived strains of lactobacillus and bifidobacterium produce gamma-aminobutyric acid. They went and took those strains that are grown in mediums containing MSG or monosodium glutamate, and growth of bacteria and conversion of MSG to GABA were measured. Of 91 intestinally derived bacteria, 1 strain of lactobacillus and 4 strains of bifidobacterium produced GABA. Lactobacillus brevis was the most efficient of the strains tested, converting up to 100% of MSG to GABA. The ability of the cultured strains to produce GABA was investigated using a simple pH-controlled anaerobic feces-based fermentation. Fun. So they basically balanced the acidity and they took it out of oxygen conditions and fermented it. Generally speaking, you're using a low oxygen hypoxic condition in order to ferment, and they took it from the feces. Lovely. So they took poop samples. Cool. And the addition to a feces-based fermentation significantly increased GABA concentration, supporting the notion that biosynthesis could occur in vivo, basically in the body. So going back to why GABA is important, it is a major inhibitory neurotransmitter of the vertebrate central nervous system and is the main inhibitory neurotransmitter in the brain, found in relatively large amounts, regulating many physiological and psychological processes, and with dysfunctions in the GABA system implicated in anxiety and depression. Like I mentioned before, a lot of times GABA agonists are used in sleep disorders and insomnia, but that's really why. It's an inhibitory neurotransmitter. MSG, as I mentioned before, which I'm sure we'll get into in a second, is an excitatory neurotransmitter. So free glutamate specifically, but monosodium glutamate being the most common dietary version. But a number of further potential health benefits of GABA have been described, including control of growth hormone secretion, protective effect against glycerol-induced acute renal failure in rats, and anti-proliferative activity, a reduction of the induced migratory activity of SW480 colon carcinoma cells. Yeah. Yeah. Interest in the potential role of GABA as an antihypertensive dietary component was recently increased in Japan. That was particularly due. This was due in particular to the high sodium intake in the diet of that country, where daily intake of salt has been estimated to be 112 grams per day. What? Is that 11? Is that a one? What? That is no way. It's gonna be 11.2. That dot is in a really weird place. There's no way it's 112. No, it's got to be 11.2. Interestingly, foods enriched with GABA have been defined as foods for specified health use in Japan, or foshu. I like it. This led to increased research into the development of fermented products containing GABA. Inoue developed a fermented milk product containing GABA, which was shown to have a blood pressure lowering effect in spontaneous hypertensive rats and in mildly hypertensive people. Very cool. Recent years have also witnessed an increase in development of additional GABA-enriched fermented dairy, soybean, kimchi, and juice products, which could be used as potential GABA delivery vehicles. I wonder if kombucha could also be done so. I'm going to go out on a limb and say yes. All right. So, in parallel, the heightened interest in the possible physiological effects following the consumption of GABA-enriched fermented food, there was a concomitant surge and isolation of novel fermented food-derived or dairy starter cultures with the ability to produce GABA. Lactic acid bacteria from food sources has been shown to have the ability to produce it, and GABA is produced primarily from the irreversible alpha decarboxylation of L-glutamate by the enzyme glutamate decarboxylase, a pyridoxal 5-phosphate dependent enzyme. Yeah, that what I said. Those things, those words. It's been found in animals higher in plants. All right, it's been found in animals, higher plants, and bacteria where it plays a role in acid resistance. Many studies have reported the presence of GAD gene in lab. And indeed, GABA has been produced by cheese starters during cheese ripening. It is clear that one approach to increasing GABA levels in humans by consuming GABA-enriched food products. However, another potential way of increasing GABA levels in the gut could be through harnessing production ability by of the intestinal microbiota or ingested probiotic bacteria that could be used to modify dietary monosodium glutamate to generate GABA. So the purpose of the study was to screen human intestinally derived bifidobacteria and lactobacilli for the ability to produce GABA as a first step in the investigating the latter strategy. And don't mind my flubbing of the words. I've been up since 5. I had a long day. Sorry. All right, and I actually had to cover over at Laura May and Islip tonight. That's part of the reason why we had to push it out to 9 tonight. But hey, we're here. So going through the methods, basically explaining how they went and derived it, amino acid analysis, statistical analysis, etc., etc., etc. Let's go through growth and the gamma aminobutyric acid GABA production by Lactobacillus brevis in the presence of 30 milligrams per milliliter of monosodium glutamate, and it's in a logarithmic scale, so that's why you see it looked a quick jump right there. So it's a logarithmic scale of their colony-forming units, and we see a big jump. So discussion, let's jump right down to there. Bifidobacterium and lactobacilli are reported to produce a wide range of metabolites, which act as a basis of probiotic function, including vitamins. I'm just going to take that off. It's getting annoying. All right, let's try that again. Range of metabolites which may act as a base for probiotic function, including vitamins, bacterio, bacteriocins, bacteriocins, yeah, that word, exopolysaccharides, and conjugated linoleic acid. Huh, that's fun too. A further metabolite produced by intestinal lactobacilli and bifidobacterium that may be linked to desirable host effects is GABA. It has been suggested that microbially produced GABA in the gut may have an effect on the gut-brain microbiome axis, an emerging concept in the health said to be crucial for maintaining homeostasis. The study was undertaken to assess the ability of intestinally derived strains of lactobacilli and bifidobacterium to produce GABA from MSG. It would appear that the prevalence of GABA-producing lactobacilli and bifidobacteria in the human gastrointestinal tract is not as widespread as it is among food-derived LAB. I remember seeing it before, whatever the hell it means. Where GABA-producing, lactic acid bacteria. Yes, is not as widespread as it is among food-derived lactic acid bacteria, where GABA-producing lactic acid bacteria have been isolated from tempeh, fruit juices, and fermented dairy and soy products. 5 of the 91 human-derived lactobacilli have the ability to bioconvert MSG to GABA. So in the study, Lactobacillus brevis and Bifidobacterium dentium were the most efficient producers, and brevis strains isolated from food sources have previously been shown to reported to produce GABA. However, in this case, brevis DPC 6108 and the 4 Bifidobacterium strains were isolated from the human gastrointestinal tract. All right. So moving through, the resulting GABA is exported from the cell via an antiporter, increasing the value of cytoplasmic pH. Because of the removing of hydrogen ions, important. It is clear that while some intestinally derived bacteria are capable of producing GABA, it is also utilized by intestinal bacteria. While it is apparent that bacteria of the gut microbiota can produce and utilize GABA, in vivo studies are required to ascertain whether the host will benefit from the microbially produced GABA or if the GABA would be utilized by members of the gut microbiota. A criterion of probiotic bacteria is that they confer beneficial effects on the host. It has been suggested that the in vivo action of GABA-producing intestinal bacteria acting on dietary glutamate could have potential health benefits. It is tempting to suggest that because of the beneficial health effects of GABA, the ability of strains of bifidobacteria and lactobacillus, natural inhabitants of the intestine, to convert MSG to GABA may be considered as a novel probiotic trait. In addition, the discovery of lactobacilli and bifidobacterium with the ability to synthesize GABA may offer new opportunities in the design of improved health-promoting functional foods with the benefits of enriched GABA and probiotic bacteria. So, short version on what the hell that actually means is that it appears that the amount of GABA produced outside of the gut is from foods is larger than the amount that is produced by those same bacteria inside the gut. So, depending on where it was sourced from. Now, that being said, this study was done in vitro. There was a simulated in vivo experiment. So basically, they tried to replicate the gut conditions, and in doing so, they found that yes, it is producing GABA. Now, whether that GABA is actually making it to the brain, it does not appear so in this particular study. What that means is that it may not have the same effects as if you were taking GABA in and of itself or consuming it otherwise. Now, what's otherwise is important to note here. Besides the production of that GABA, the conversion of the MSG is huge. So rather than having free glutamate floating around, what these bacterial strains could do is actually remove that free glutamate, making it less neurotoxic, less neuroexcitatory. And as such, it explains yet another mechanism by which your gut can help to improve your brain. Crazy stuff. So, having established all that, let's make our way to the original paper I came across, which is, yes, Psychobiotics and the Manipulation of the Bacteria Gut-Brain Signals. All right, psychobiotics were previously defined as live bacteria which, when ingested, confer mental health benefits through interactions with commensal gut bacteria. We expand this definition to encompass prebiotics. What are those? Well, you'll find out. Now, they enhance the growth of beneficial gut bacteria. Now, we've talked about those before, and basically, they are the fuel for probiotics. They are the fuel for the commensal bacteria of your gut. Now, we review the probiotic and prebiotic effects of emotional, cognitive, systemic, and neural variables relevant to the health and disease. We discuss gut-brain signaling mechanisms enabling psychobiotic effects such as metabolite production. Overall, the knowledge of how the microbiome responds to exogenous influence remains limited. We tabulate several important research questions and issues, exploration of which will help to generate both mechanistic insights and facilitate future psychobiotic development. We suggest the definition of psychobiotics be expanded beyond probiotics and prebiotics to include other means of influencing the microbiome. Well, let's find out what they're talking about then. What is that one? Use condition preference. Interesting. Maybe we'll come back to that. We'll see where we're at. All right. Psychobiotics are beneficial bacteria probiotics or support for such bacteria prebiotics that influence bacteria-brain relationships. Psychobiotics exert anxiolytic and antidepressant effects characterized by changes in emotional, cognitive, systemic, and neural indices. Bacteria-brain communication channels through which psychobiotics exert their effects include the enteric nervous system and the immune system. Current unknowns include dose responses and long-term effects. The definition of psychobiotics should be expanded to any exogenous influence whose effect on the brain is bacterially mediated. The gut microbiome comprises all microorganisms and their genomes inhabiting the intestinal tract. It is a key node in the bidirectional gut-brain axis that develops through early colonization and through which the brain and gut jointly maintain an organism's health. A pivotal study found that mice raised in sterile environments and therefore lacking indigenous bacteria, germ-free mice, showed exaggerated physiological reactions to stress compared to normal controls. The abnormal reactions were reversible through probiotic-induced bacterial recolonization. This finding revealed that the microbiome's causal involvement in the development of the hypothalamic pituitary adrenal or HPA axis. Gut bacteria have since been found to participate in the regulation of varied and important physiological processes, including immunomodulation, adiposity, and energy balance, as well as the electrophysiological activity of the enteric nervous system. What the hell does all that mean? Well, your gut bacteria, if they are the right types, you get good effects. If they are the wrong types, you get bad effects. Where can it be regulated through? Well, they have a causal involvement, not just correlational, not just they are linked to it, they appear to be associated with. No, they have a causal, they have a direct effect on the HPA axis, which we've talked about is a huge component to your stress response. Your adrenals are one of your biggest regulators of your stress response. And how do they do that? Well, they do it through negative feedback loops. It's part of how they do it, but they do it through negative feedback loops, kicking back information to your hypothalamus up in the brain, which then sends down to the master gland, the pituitary, and sends information back out. Now, that also now has effects on your gonads as well as your thyroid. So the reason why we have our HPA, we have our HPT, and our HPG axis. And in fact, since we were just talking about the negative feedback loops and how they play a role in the HPA axis, HPG axis, T axis, excuse me. Almost misspoke there. Imagine that. What I'm going to do is I'm going to drop a card. I'm going to drop a card for that one right up top as well. So you'll be able to find that over there. Yeah, that area. And bam. All right. So now, moving back to what we're talking about here. When we're talking about the HPA axis, that's your stress response. From there, physiological processes including immunomodulation, regulation of your immune system, adiposity, your fat levels that you have going on, and energy balance, basically the amount of calories that A, you're taking in, or B, you're actually burning. So it helps to regulate the level of calories that you're actually taking in and out, your energy balance. So probiotics, beneficial bacteria that yield positive health outcomes, have received particular attention, both in the popular press and the research community. Here, we critically evaluate efforts to manipulate commensal gut bacteria with psychobiotics. These psychobiotics were first defined as probiotics that, when ingested in appropriate quantities, yield positive psychiatric effects in psychopathology. The bacteria most frequently exploited as probiotics are the gram-positive bifidobacterium and lactobacillus families. Bifidobacteria and lactobacilli do not possess pro-inflammatory lipopolysaccharide chains, and so their propagation in the gut does not trigger full-fledged immunological reactions. Now, we've talked about LPS before a couple of times. They are an endotoxin. They are a toxin produced in the cell walls of those gut bacteria. Now, particularly the generally pathogenic gram-negative bacteria. When those bacteria die, well, that toxin gets released, or when those bacteria overproduce, or when they overproliferate, then they can release a bunch of LPS as well. But when they get killed and they have to go somewhere, they are releasing a bunch of LPS then as well. And that's often why we see people who try to either A, go on antibiotics, or B, modulate their gut bacteria some other way, often see some serious, Herkimer effect, healing crisis, whatever you want to call it, because those toxins have to go somewhere. So those bifidobacteria and lactobacilli do not possess the LPS. Just a quick side note. So with the presence of such bacteria, the immune system learns to distinguish between pro-inflammatory and anti-inflammatory entities and develops appropriate immunogenic responses by identifying the pro-inflammatory elements as antigenic. It should be noted, however, that gram-positive bacteria are not always beneficial, and some, such as Clostridia family, may be pathogenic. So like I said before, a lot of the pathogenic ones are gram-negative, and that's where the LPS is coming from. Things like Clostridia can, in fact, be negative. They can be deleterious. All right. We propose the definition of psychobiotics be expanded along two dimensions. First, research on healthy individuals is demonstrating that psychobiotic benefits need not be restricted to clinical groups. Basically, we've talked about the phases of clinical trials. In the initial phases, they test it on a healthy population. Then they test it on in phase 2, they go and test it on a population that is small scale and not necessarily the worst cases. From there, they can actually go and take it to phase 3, in which case they are going with the worst, the actual target group. Phase 4 is afterwards, once after market, they kind of test it afterwards again to make sure that the safety is kind of adequate. Anyway, the initial clinical trials are demonstrating that psychobiotics are beneficial and not problematic. Second, we include, not to conclude, we include prebiotics in the definition of psychobiotics. Prebiotics are compounds that, when fermented in the gut, produce specific changes in bacterial composition or activity. Prebiotics support the growth of intrinsic commensal bacteria. The majority of prebiotic compounds examined for their neural effects are fructans and oligosaccharides, comprising 3 to 9 saccharide units. This review will 1. Discuss psychobiotic effects on emotional, cognitive, systemic, and central processes in animals and humans in clinical and healthful populations. And 2. Assess the microbiome, brain signaling mechanisms enabling these effects. Now, quick rewind on that for a second. Those fructans and oligosaccharides, they may sound familiar to some of you. We've talked about FODMAPs before, which are fermentable, oligo, mono, disaccharides, and polyols. Those are the FODMAPs. Fructans do fall under the category of disaccharides. Pretty sure about that. Mono or di. They are a saccharide in the FODMAP category. And oligosaccharides, which are a group of saccharides, many saccharides. All right. Long and the short of that is I kind of tangentially sidetracked there. FODMAPs can be particularly problematic in certain individuals, generally indicating that you have an overgrowth of the pathogenic or deleterious, the bad kinds of bacteria. So you have to be a little bit more careful when you're going through that, because those prebiotics can feed those as well. That's why certain people who are particularly far gone with dysbiotic gut will often do better lowering the carbohydrate intake. The reason being, you are starving those bacteria. So, yeah. All right. Psychophysiological effects of psychobiotics. Much psychobiotic research is based on rodent models, which use rodent stress inductions and rodent behavioral tests to assess motivation, anxiety, and depression. Psychobiotics applied to rodent models of illness, infection, and neurodegeneration also provide early clinical insight into human diseases. Human investigations represent a very recent trend, and the psychophysiological effects of psychobiotics fall into the following three categories. One, psychological effects on emotional and cognitive processes. Two, systemic effects on the HPA axis and glucocorticoid stress response. Glucocorticoids, round 17. Glucocorticoid stress response and inflammation, which is often characterized by apparent cytokine concentrations. Pro-inflammatory cytokines share a strong and well-studied positive association with psychiatric conditions such as depression. For example, injection of interferon alpha, a pro-inflammatory cytokine, has been shown to induce depression, which can be alleviated through antidepressant action. And 3, neural effects on neurotransmitters and proteins. And to backtrack, because I paused for so long after the 17 mess-ups on glucocorticoids, those are among the 3 categories of psychophysiological effects of psychobiotics. Yeah. Relevant neurotransmitters include gamma-aminobutyric acid, or GABA, and glutamate, which control neuroexcitation inhibition balance. Proteins include brain-derived neurotrophic factors, which we talked about last week, which play a crucial role in learning and memory processes, including spatial learning, extinction of conditioned fear, and object recognition. BDNF is reduced in anxiety and depression, a reduction that is reversible through antidepressant action. Antidepressant action. Enunciate your words. Yeah, that thing. Moving forward, psychobiotics are psychophysiological markers of anxiety and depression. Affect those. They aren't just those. They affect those markers. One study employed a maternal separation model to induce early life stress in infant male Sprague Dawley rats. These rat pups were either undisturbed, there were 33 in the start, that was a sample size. They were either undisturbed or, if separated, administered with either a neutral vehicle substance, an antidepressant, such as the selective serotonin reuptake inhibitor, citalopram, or the probiotic Bifidobacterium infantis. Vehicle rats showed typical psychophysiological patterns associated with maternal separation, including poor performance on the forced swim test and increased inflammation indexed by heightened peripheral concentrations of the pro-inflammatory cytokine interleukin-6, decreased presence of the neurohormone noradrenaline in the brain, and elevated concentrations of amygdala corticotropin releasing factor messenger RNA, or messenger ribonucleic acid. In comparison, these indices were normalized in probiotic-fed rats. So, what happened? We see more inflammation in those that had the maternal separation and didn't really get much, and those that had the probiotic feed, well, they seem to do a lot better. Their indices, the markers that were being reported on, they were normalized. Moreover, these outcomes were comparable to those observed in the citalopram group. So, basically, suggesting that some probiotic benefits resembled those of antidepressant effects. These findings were reminiscent of an earlier work where a mixture of Lactobacillus rhamnosus, R0011, and Lactobacillus helveticus, R0052, downregulated HPA axis activity, indexed by normalized corticosteroid secretion, and mitigated colonic dysfunction in maternally separated Sprague Dawley rat pups. So, basically what we're looking at here, colonic dysfunction. Basically, they got constipated, or they had the runs because they were so anxious. More likely, they got constipated, but it's pretty funny. Helped to fix that though. They weren't as constipated anymore, and it also helped to relax them in terms of their overstressed response. In the case of non-clinical populations, experiments are defined by psychobiotic supplementation in rodents that have unimpaired psychophysiological processes and microbiomes. For example, one study examined the effects of probiotics in healthy adult BALB-C mice, which were innately stress-sensitive and anxious but otherwise healthy. Compared to mice administered a vehicle, those fed Lactobacillus rhamnosus JB1 expressed fewer depressive and anxious behaviors in the forced swim test and elevated puzzle plus maze tasks, respectively. These behaviors, these changes were accompanied by a blunted corticosteroid response to stress, suggesting that probiotic downregulated HPA axis activity. In the brain, probiotics differentially altered expression of inhibitory GABA receptors in the region-dependent manner. For instance, in comparison to controls, the probiotic reduced expression of GABA B1B mRNA in the hippocampus and amygdala, but increased its expression in the prelimbic and cingulate regions. GABA is the chief inhibitory neurotransmitter in the nervous system. Overall, probiotics may modulate regional excitation inhibition balance, and these changes may be linked with reductions in anxiety and depression-related behavior and associated systemic response. So, we mentioned before, GABA is a one that can help to inhibit neuroexcitation or an overreaction of the brain, whereas glutamate is one that can go and cause an excitation. It can cause the brain to be overstimulated. So we saw before in the other paper that we stumbled upon that GABA can be produced from monosodium glutamate. So people get MSG and they get the neuroexcitation. Well, different bacteria are able to take that and produce GABA. So before we saw that they actually can produce the GABA. Here we're seeing how they can actually change the expression of the GABA receptors, basically change the way the GABA receptors are reacting. So, incredible stuff. In another study, healthy adult male BALB, again, to be clear, this is being done in mice studies, but we'll get to the humans later. I'm pretty sure I mentioned that. But in another study, healthy adult male BALB-C mice were fed Mycobacterium vacii. I've never seen that one. You got me. N equals, so their sample size was a 7 to 10 group across 5 experiments. Displayed reduced anxiety in maze learning tasks. Furthermore, performance of the maze task was substantially improved in the probiotic-fed mice, which completed the maze faster and with fewer errors. Benefits that persisted at 1 week but not 3 weeks post-treatment. These results provide preliminary but important evidence of the potential longevity effects, an area that has received little consideration in psychobiotic research. Essentially what they're saying is that while there were cognitive benefits after a week, there were not after 3 weeks, meaning that those strains that were utilized there may have had systemic effects. They may have been able to affect the body as a whole, but not in the long term. Now, what's interesting about that happened for 2 main reasons. One is that the commensal bacteria, the beneficial ones that were in that probiotic, did not colonize. They did not take root and replace the pathogenic ones. And 2, and this is likely concurrent with the first one, is that the pathogenic ones, the bad ones, were able to regrow for some reason. Basically, the likelihood is that whatever caused the negative bacteria to grow, whatever caused them to basically be the predominant type continues to be the case. It wasn't eradicated, or eradicated isn't the right word. It was still allowed to be the predominant type versus the commensal one being the beneficial one being the predominant type. So because that time was able to go, it likely did not take root to a sufficient extent, and because of that, those symptoms were not still, those benefits were not as translatable 3 weeks later. Basically, keep taking your probiotics. That's a short version of that. One program of research investigated the effect of Bifidobacteria infantis on male Sprague-Dawley rats with a sample size of 20 in the forced swim test. Stress responses, inflammation, and monoaminergic activity. While there were no behavioral changes in the swim test performance, there were significant increases in tryptophan, the serotonin precursor, in the plasma. There was also decreased concentrations of 5-hydroxyindolacetic acid, the serotonin metabolite in the brain. So we've talked about the pathways in which that goes. Tryptophan is an amino acid, which then goes to produce serotonin, which then goes to produce 5-IAA, which is the 5-hydroxyindolacetic acid. And from there, it goes to produce 5-HTP. I skipped a couple of steps there. No, it goes the other way. Tryptophan to 5-IIP to 5-HTP. Tryptophan to 5-HTP to 5-IAA to serotonin. Yeah. Anyway, pretty sure. I haven't looked at that chart in a while. Huh. It's gonna bug me now. Let's see. How does ecstasy work? Serotonin pathways in the brain. Nice. 5-hydroxytryptamine is a monoalanine neurotransmitter derived from tryptophan. Yes, I know this already. But where is the 5-HTI, I1A, metabolic pathway? Where is it? Aha, winner. L-tryptophan, which then goes to 5-HTP, which then goes to serotonin, then goes to 5-hydroxyindolacetic acid. So that's why it would make sense that it is the metabolite of serotonin, or 5-HT. Got it. Awesome. Moving on. Dun, 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 dun. This was taken as evidence of reduced serotonergic turnover. Comparisons to vehicle-fed rats. Compared to vehicle-fed rats, blood from probiotic-fed rats exhibited reduced concentration of the pro-inflammatory cytokines tumor necrosis factor alpha, interleukin-6, and interferon gamma. These reductions jointly characterize a dampened pro-inflammatory response. This approach highlights the importance of examining physiological variables in psychobiotic research, as physiological changes were noted in the absence of significant behavioral changes. Probiotic effects during stressful experiences have also been examined. Healthy adult male spray dolly rats were administered Lactobacillus helveticus NS8 citalopram or no intervention while exposed to chronic restraint stress. So again, there's another one. We're looking at rats, comparing a probiotic, a SSRI antidepressant, and a control group where no intervention is utilized. And while exposed to chronic restraint stress. I feel like I may have just said that. Anyway, their sample size was 24, with a total across all the treatment groups, including 8 in an undisturbed group. Relative to the control group, the probiotic-fed mice showed lower levels of post-restraint anxiety, assessed in the elevated plus maze and the open field test, as well as enhanced post-restraint object recognition memory. At the biochemical level, probiotic supplemented rats displayed lower levels of corticosteroid and adrenocorticotropic hormone. The probiotic group also showed increase in the anti-inflammatory cytokine interleukin-10 and hippocampal BDNF, mRNA, noradrenaline, and serotonin. Overall probiotic and antidepressant effects were comparable. So again, another study, again in rats, but indicating that SSRIs and probiotics are equally effective. Recent work has also studied psychobiotic-induced changes in central neurotransmitter concentrations in vivo utilizing magnetic resonance spectroscopy, or MRS. Healthy adult male BLBC mice were administered with either Lactobacillus rhamnosus JB1 or vehicle for 4 weeks. Probiotic-fed mice showed elevated concentrations of glutamate and glutamine, total N-acetylaspartate, and N-acetylaspartyl-glutamic acid, N-acetylaspartyl-glutamic acid, or TNAA, and GABA. The authors interpreted TNA changes as a marker of alterations in neurometabolism resulting from the intervention. Glutamate is the chief excitatory neurotransmitter in the central nervous system, and To the best of our knowledge, this is the first demonstration that it is sensitive to probiotics. That is incorrect because the one before talked about that. The GABA being produced by lactobacillus. So, unless that recent work is the one that we just cited, in which case I'm an idiot. No, it's 2016. Oh no, even better. So this one is actually what they're saying here is that this is the first one that shows actually affecting the brain. We said that before, that we weren't sure whether or not it would actually be going on to affect the brain, that it was working in vitro, but that this is actually indicating that it will actually have an effect in vivo. Sweet. So this is the first time that we've seen that it is actually more effective in vivo. Awesome. Furthermore, because GABA and glutamate have opposing effects on neural excitability, it is possible that the total psychobiotic effect may be occurring within a zero-sum framework. The researchers have conducted periodic MRS, finding the differential rates of emergence for the effects. For example, NAA increased after 2 weeks of probiotics, an elevation that was sustained for the remainder of the supplementation, and which returned to baseline 4 weeks thereafter. Glutamate and glutamine levels also increased after 2 weeks, and then remained elevated for a further 6 weeks, including 4 weeks after the intervention. Finally, GABA concentrations were only elevated in the 4th week of the intervention, but not before or after. These results represent a crucial step in determining emergence and longevity effects. The general consensus is that ingestion of probiotics results in transient rather than permanent colonization of the gut. These results suggest that psychobiotics may have some long-term effects and that the effects have differential longevity. So basically, it has both effects potentially. So short version, like we were saying before, is that taking those probiotics may not actually result in permanent colonization. So that is actually the way I postulated it before, was that they may not be the end result. They may not be able to cause permanent change. They may not be taking a full resident. Now, that being said, when we're looking at these strains here, they have effects on GABA, they have effects on the glutamate, they have effects on, just blanked out. Basically, they have, yes. So they have effects on being able to increase the GABA and reduce the glutamate, which again, it will have that zero-sum balance. So it'll be able to have beneficial effects on both reducing the excitation and improving and the increase of more inhibitory molecules. So in doing so, it helps to regulate that balance. So in people that are overly excited, could be very beneficial. But because it has more transient effect, you're going to want to do it a little bit longer term. While it may last a couple of weeks after supplementation, the long and the short of that is long term, not going to work as well with targeted doses. Now, a much smaller number of studies has examined the psychophysiological effects of prebiotics. These include investigations of galacto-oligosaccharides and fructo-oligosaccharides, or GOS and FOS, which are a source of nutrition for bifidobacteria and lactobacilli and stimulate their activity and propagation in the gut. The first report of the psychobiotic properties of prebiotics examined, of course, wait for it, adult male Sprague Dawley rats. With a sample size of 24, they were administered the Bifumo formulation of GOS, FOS, or water over 5 weeks. Relative controls, prebiotic ingestion increased hippocampal BDNF expression and BDNF mRNA in the dentate gyrus. Prebiotic feeding also increased N-methyl-D-aspartate receptor, or NMDAR subunits expressed in the hippocampus. These receptors play an essential role in maintaining synaptic plasticity and optimal memory function. Both BGOS and FOS elevated NR1 subunit expression in the hippocampus, with BGOS additionally increasing NR2A subunits in this region, and NR1 and D-serine in the frontal cortex. Yeah, we're getting pretty deep into this one, aren't we? The more widespread BGOS effect relative to SOS may reflect the former's greater bifidogenic capacity. So basically helping to produce more bifidobacteria. There's also evidence of substantial benefits conferred by human milk oligosaccharide 2-fucosylactose. Yeah, there was just a period, pause, end there. Yeah, relative vehicle male rodents, both Sprague Dolly and C57BL6 rat mice, showed enhanced associative learning and working memory, as well as higher expression of hippocampal and striatal BDNF and increased hippocampal long-term potentiation. So, we are looking at improved memory. Now, prebiotic supplementation has been studied in neonatal rats. Male and female Sprague Dolly rat pups were fed daily, with a sample size of 48, with BGOS or control solution from postnatal day. Postnatal day 3 to 21. Animal supplemented with BGOS expressed higher levels of hippocampal BDNF and NMDAR subunit glue N2A. Ugh. Crucially, these changes were observed even 26 days after treatment cessation. A similar effect of human milk oligosaccharide was observed in male Lister hooded rat pups. Relative to vehicle, rats were fed the prebiotic during lactation showed substantially enhanced maze learning and object recognition 1 year later. These findings have important implications for assessing the longevity of prebiotic effects and are suggestive of very long-lasting gains. So, to recap, the probiotics before seem to have transient effects. We're looking at generally we'll see effects of upwards of 1 to 2 weeks, occasionally upwards of a month, but generally after that, most of the effects have dropped off. This here seems to indicate that the memory effects from the prebiotics can last upwards of a year after the initial intervention. That's incredible. But that's enough rats. What about humans? That's the important stuff, right? I mean, I guess you might want to make your pet rat kind of smart, but then he might try to take over the world, and who wants that? Anyway, probiotics. The rodent-human translation has been surprisingly robust. It's a robust feminist argument. Though many more human studies are necessary, it is important early investigation. Male and female participants consumed either a fermented milk drink containing Lactobacillus casei, Shirota, my Shirota, or a placebo. This contained a sample size of 124 people. At the end of the 3-week intervention, there was no overall changes in self-reported effect. However, when only participants whose baseline mood scores fell in the lowest third of the total range were analyzed, probiotic supplementation resulted in significantly more participants self-rating as happy rather than depressed relative to placebo. These results suggest the emotional benefits of psychobiotics may be subject to ceiling effects, though research also found that probiotic-fed participants performed lower on 2 assessments of memory function. This may be attributable to chance, as the authors themselves have suggested, but it may possibly imply detrimental effects of antibiotics. Now, yeah, I'm definitely leaning towards that being more of a more of a random chance of it. But that being said, it's always a possibility. You kind of have to leave it out on the table, the alternative hypothesis. Regarding the lowest third aspect, the fact they went and isolated the lowest third percentile. And what we're looking at there is basically those who had the worst mood scores happen to have incredible benefits. They had a significantly more people reporting as self-reporting as happy rather than depressed after taking that lactobacillus fermented milk drink, lactobacillus casei. So basically, in those who are were more depressed, it seemed to actually have a more beneficial effect. In the bottom third, the most depressed, those are the ones who saw the biggest benefit. Why? There might be a cap. After a certain point, you're not going to see more happiness. The bacteria are, again, we talk about that a lot. They're not here to overly stimulate you. They're not here to overly depress you. And that's in the literal sense, not depression, but more in the sense of the physiological effects. It's not meant to give you a spike. It's not meant to drop you. Whether that be mental health, whether that be immunological, whether that be stress related. they are more likely to have just simple, straightforward regulatory effects, bring you back to homeostasis. Okay. Another well-known study provided evidence of improved mood in generally healthy sample. In a randomized and double-blind design, healthy male and female volunteers with a sample size of 55 consumed either a mixture of probiotics, Lactobacillus helveticus R0052, and Bifidobacterium longum, or a placebo over 30 days. After which, participants completed a range of self-reported measures on mood and distress. Participants also collected over 24 hours before urine. What do they collect? Urine over 24 hours before and after intervention, enabling cortisol estimations. Relative to placebo, probiotic-treated participants showed significant declines in self-reported negative mood and distress. Parallel to these changes was a decrease in urinary free cortisol, which is suggestive of reduced stress. Interestingly, a follow-up analysis of these individuals with the lowest stress index by cortisol concentrations showed similar effective benefits to those with higher cortisol concentrations, to some extent contravening the role of ceiling effects in determining psychobiotic outcomes. So, basically, in the follow-up outcome, the individuals with the lowest stress, those who had the biggest problems, showed similar effective benefits to those with the highest cortisol concentrations. Basically, showing that maybe it's not the exact case. But the research also investigated potential detrimental effects, including probiotic-induced impairments in learning and memory, which the previous study had indicated might be the case. However, there was no evidence of dysfunctions and learning and memory. And furthermore, the probiotics did not induce addiction, suggesting a good safety profile without concomitant, I can't always pronounce that word, concomitant cognitive impairments. Close enough. I'm done. I'm done trying to say the word. Done. I'm done. I'm done trying to say that word. All right. Moving along. Similar effects have been observed in other investigations of mood. For instance, in a recent randomized controlled trial, healthy male and female participants with a sample size of 40 consumed either a placebo product or a mixture of several probiotics, Bifidobacterium bifidum, W523, whatever, all those strains. Those guys. I'm not repeating those words 100 times. It was a bunch of lactobacillus, a couple of two bifidobacterium, and a lactococcus lactis. Yeah. Over a period of 4 weeks. Relative to placebo, probiotic-treated participants exhibited substantially reduced reactivity to SAD mood, an effect that was specifically attributable to reduced rumination and aggressive cognition. All right. Lactobacillus casei shirota has also been recently employed in an intriguing study of academic stress. Healthy male and female students, 40 with a sample size of 47, consumed either their probiotic or a placebo for 8 weeks before a medical school examination. Physiological measures were obtained for the duration and after the examination as well. The probiotic group had substantially lower plasma cortisol levels compared to the placebo group on the day before the examination. 2 weeks post-examination, the probiotic group showed significantly higher fecal serotonin, though the psychological implications of this set change are less clear. Another study found that relative placebo student athletes with a sample size of 44 fed Lactobacillus gasseri showed elevated mood and reduced natural killer cell activity after strenuous exercise, and with some additional alleviation of fatigue when the probiotic was consumed alongside alpha-lactalbumin. These results suggest that probiotics may have ecologically relevant benefits and the potential to enhance performance on some important life activities. Nice. Some evidence for the immunological effects of probiotics in humans derives from a study in individuals with irritable bowel syndrome, which is associated with disturbances in the gut-brain axis and in the composition of the microbiome, and is often accompanied by anxiety and depression. Male and female participants consumed Lactobacillus salvarius or Bifidobacterium infantis or a placebo. At baseline, participants had an apparent ratio of interleukin-10 to interleukin-12, suggesting a generalized pro-inflammatory state. Only those who consumed Bifidobacterium infantis displayed a normalization of this ratio post-treatment. These results indicate that probiotics can induce cytokine changes in humans and also that the effects may be specific to particular families or strains of probiotic. However, there is no theoretical basis at present to predict that one form of probiotic will be more effective than the other. Essentially, it's tough to say which ones are going to be the winners when it comes to those beneficial effects. All right. What neural and information processing changes might underpin these probiotic-induced emotional benefits in humans? Well, evidence from a neuroimaging study points to modulation of attention and vigilance to negative emotional stimuli. Over 4 weeks, healthy female participants consumed either a placebo or a mixture of probiotics, or consumed nothing as part of a passive control with a sample size of 36. Crucially, participants underwent functional magnetic resonance imaging or functional MRIs to determine how probiotic ingestion affected neurophysiological activity. During image acquisition, patients or participants were shown emotional faces that were known to capture attention and cause brain activation, fearful faces in particular. Relative to placebo, probiotic-treated participants showed decreased activity in functional network associated with emotional, somatosensory, and interoceptive processing, including somatosensory cortex, the insula, and the periaqueductal gray. Placebo participants showed increased activity in these regions in response to emotional phases. This can be interpreted as a probiotic-induced reduction in the network level of neural reactivity to emotional information. Basically, those fearful faces, they ended up having less of a problem. They were able to have a better effect. They did not get emphatically as upset in relation to the emotionally provoked response to those pictures. So, good thing. Improved mood. All right, prebiotics in humans. Inductive evidence that psychobiotics modulate emotional appraisal is supplied by the first human study to examine the psychophysiological effects of prebiotics. Healthy male and female participants with a sample size of 45 consumed either BGOS, FOS, or a placebo. In comparison to the other two groups, participants who consumed BGOS showed a significantly reduced waking cortisol response. Exaggerated waking cortisol is a biomarker of emotional disturbances such as depression. Furthermore, participants completed an emotional dot probe task that measures vigilance or attention to negative stimuli, which is also a behavioral marker of anxiety and depression. BGOS attenuated vigilance, suggestive of reduced attention and reactivity to negative emotions. Attenuated vigilance is considered an anxiolytic and antidepressant effect. So they basically were able to help to attenuate that vigilance, basically bring down the fearful response and had anxiolytic or anti-anxiety, antidepressant, anti-combating depressive effects. Overall, these psychobiotics may exert their beneficial effects on mood through modulation of neural networks associated with emotional attention. The addition of behavioral measures of vigilance, cognitive control, and negative mood to research programs would richly supplement self-reports. Moreover, their addition is logistically straightforward and incurs minimal additional resources. Reduced attention to negative stimuli may constitute a neurocognitive channel through which psychobiotics might improve mood. At the systemic level, reductions in cortisol and pro-inflammatory cytokines would support these processes, given their frequent co-occurrence with a negative mood. At present, however, the direction of causality between systemic and brain changes is unknown. Furthermore, longevity and time course effects have not been studied in humans and are even less clear in rodents. All right, we have bacteria and brain signaling, vagal signaling through the vagal nerve, short-chain fatty acids, gut hormones, and bacteria-derived blood metabolites, bacteria immune reactions, glucocorticoids, and the gut barrier, making sure that the barrier itself is intact. So basically going through how it can have immunologic effects, how it can have endocrine effects through the hormones, how it can have anti-inflammatory effects, how it can have gut healing effects, how it can have nerve transmission effects through vagal signaling, as well as through just general enteric nervous system. We're going to skip through all of that because we're already past the hour mark. But again, I have linked this article down in the description. You can finish that part up yourself. What we'll close out with then is just the future directions and psychobiotics beyond pre and probiotics. All right, we'll close with that. Yep. Narrative reviews of psychobiotics, including this one, are largely enthusiastic about the field. However, a recent systemic review of psychiatric benefits of probiotics in humans found little evidence of positive outcome, a finding running counter to the general optimism. Others have stated that the field, though not fecal phrenology, will ultimately be unable to provide true translational value without rigorous elucidation of mechanisms. Numerous limitations must both constrain enthusiasm and stimulate further investigations. For example, many studies examine several psychophysiological variables, of which only a few register effects. While exciting, issues of false positives and false negatives have not been adequately investigated. To a larger extent, greater statistical power will add resolution. However, a range of conceptual and technical issues require exploration, which will both provide further mechanistic insights and pave the way for emergence of systemic efficient psychobiotics. Now, I've talked before about the problem with most probiotics, right? We've talked about that quite a few times, right? The problem is that most of them are not going to survive through the transit of the gut. Because of that, that's why something like Megaspore is so important. The fact of the matter is, when you are consuming those bacteria, or when you are consuming those probiotics, very often they're not getting all the way through the system. Because of that, that does confound the research a little bit, because if they're not actually getting into your system, they're not going to be able to have systemic effects. So that's where something, again, like Megaspore, Bacillus strains might be the winner. So I put the link to the card up top over here. You can take a look at that. You can take a look at the over here. Yeah, over there. So you take a look at that. Drop the card for the spores and why that is important. But yeah, let's finish this up. Basically, despite all the excitement, they're trying to say, just be mindful that it's not the, that we don't have the study of it all done yet. Yes, I understand. But there are limitations to the current frame of reference with respect to the strains that are being used, particularly since we've seen that they are transient in nature. That can be a problem. So, yeah. All right, so let's finish this up. It is also worthwhile considering a wider definition of psychobiotics that need not be limited to probiotics and prebiotics. Indeed, any substance that exerts a microbiome-mediated psychological effect is potentially a psychobiotic, or at least possesses psychobiotic properties. For example, ingestion of the antipsychotic olanzapine has been shown to increase relative abundance of actinobacteria and proteobacteria and is associated with weight gain. However, a mixture of antibiotics, neomycin, metronidazole, polymyxin, has also been shown to ameliorate the effects of olanzapine on the relative abundance of bacterial families and can commit weight gain in rats. Antibiotic mixtures such as bacitracin, neomycin, and pictamarin have been shown to induce neurochemical and behavioral changes through effects on the microbiome. And you know what? Let's pop that one into the cards as well, because should you be taking probiotics while on antibiotics? And the answer, of course, is yes. So we'll just drop that one in as well. And you'll be able to find it up top along with the rest of the videos. All right. So basically what they're showing is that in this case, the antibiotic one will be beneficial because that particular antipsychotic actually caused weight gain, partially through the increase of the deleterious bacteria. So the antibiotics go and take that off. So therefore, both antibiotics and antipsychotics may be classified as psychobiotics because they both have effects on the bacteria. Their effects on commensal bacteria illustrate the importance of considering the microbiome in side effect assessments during clinical trials, which is currently not on the research agenda. Indeed, many substances exert secondary psychobiotic effects through the microbiome alongside their primary intended effects. Some of these areas are being explored in the emerging field of pharmacomicrobiomics. Beyond medical signals, the microbiome is sensitive to diet and exercise, both of which affect mood and cognition, and both of which affect vagal activity. Therefore, sharing a signaling mechanism with other psychobiotics. It is possible the psychological effects of diet and exercise are partially mediated by the microbiome, and in this case, an argument may be made for them possessing psychobiotic properties. More broadly, and consistent with cultural variance in diet and environment, there are geographical differences in the microbiome, both in infancy and adulthood. So, there you go. Psychobiotics, probiotics, prebiotics, and otherwise things that affect your gut bacteria can affect your brain, period. Write that down. All right, guys. I'll hopefully you enjoy this one. You know what to do, like and subscribe, all that fun stuff. Yeah. Links down in the description for those articles. You can read through them yourself a little more, dissect, analyze, get back to me. You know the deal. Love you. And I guess I will, well, my test is next Sunday. Hopefully I'm done with that and things won't be as crazy when we get back to more regular videos. We'll figure it out. Either way, guys, keep your eye posted for the fire cream. Stay, like it down below, and love you, and I'll see you next week.